everyone, in this video we're going to talk about geometric sequences. The ratio between each pair of consecutive terms is the same. Okay, so the ratio, what we are multiplying by. The ratio is called the common ratio, and each term is found by multiplying the previous term by that common ratio. Okay, so let's look at a couple examples. Remember, we also talked about another type of sequence called an arithmetic sequence that had a common difference. Okay, so if you want to review arithmetic sequences, check out the video in the top right-hand corner right now. So here in this first example, we're going to see, is this sequence geometric or is it arithmetic? So example 1, we go 6, 24, 96, and 384. So it appears that we are multiplying by 4 each time, right? So since we're multiplying, we're going to say this one is geometric. Our common ratio would be 4. The next one, 10, 6, 2, negative 2. Well, we're not multiplying anything there. It looks like we're subtracting, right? We're subtracting 4. Okay, so this one is actually arithmetic. And we'd say our common difference is negative 4. Okay, so notice the difference is there. All right, so let's extend some geometric sequences here by writing the next 3 terms. Okay, so A, we have 6, negative 18, 54, and negative 162. One thing that we notice is that each term is alternating positive, negative, positive, negative. That has to mean that our common ratio is a negative number. So we see we are multiplying here by negative 3. So our common ratio is negative 3. And let's write our next 3 terms. We can say negative 162 times negative 3. And we get 486 times negative 3. Negative 1,458, and times negative 3, 4,374. Okay. All right, for B, notice that our values in our sequence are getting smaller. So we can think about division here, but remember, our common ratio is what we're multiplying by. So if we think, oh, I'm dividing by 5, right? Well, what's the same thing as dividing by 5? Multiplying by 1/5. Okay, so that's what we need to identify as our common ratio times 1/5. Okay, so our common ratio is 1/5, and now we can write the next 3 terms. So essentially we are dividing by 5 or multiplying by 1/5. So our next term, I'll just write it here, we'd have 1 over 25, then we'd have 1 over 125, and then we could take 125 and multiply by 5. So we have 1 over 625, okay? And that would be our next 3 terms in the sequence. All right, just like we did with arithmetic sequences, we can also graph geometric sequences. So arithmetic sequences graphed as linear functions. So let's see what's going to happen when we graph a geometric sequence. We're going to graph the sequence the same, okay? We're going to graph it as the x value is just the position that the term is in, right? So we can say that as n. And then the actual term itself, a sub n, is the y value, okay? So we're going to graph 1, 24, 2, 12, 3, 6, 4, 3, and 5, 1.5, okay? So we can see that our geometric sequence is multiplying by 1/2, right? 24, 12, 6, 3, 1.5. So let's graph this and see what it looks like. So 1, 24, 2, 12, 3, 6, 4, 3, and 5, 1.5. Okay. All right, so it appears that we have an exponential curve. Okay, so when we graph a geometric sequence, it will graph as an exponential curve. Okay. That will be the case anytime our common ratio is a positive number. Okay, if our common ratio is a negative number, then the graph will look a little bit differently. Okay. Last thing, there is also an equation for a geometric sequence. So we saw this once again with arithmetic sequences. Our equation for a geometric sequence is a sub n equals a sub 1 times r to the n minus 1. Okay, so really we just need to find 2 things, or identify 2 things. The first term, which is a sub 1, and then our common ratio, which is r, okay? So I'm going to go ahead and write this down. A sub n equals a sub 1 times r to the n minus 1 on both of these examples. So now we want to write the equation and then find a sub 8, which is our 8th term in the sequence. So for example A, we have 3, 12, 48, 1, 92. So our first term is 3. R is our common ratio. We are multiplying by 4. So we're going to put 4 in parentheses here, and then we just leave n minus 1. Okay, so there's our equation. Now we want to find the 8th term. So we say a sub 8 equals 3 times 4 to the 8 minus 1. Okay, well 8 minus 1 is 7. And so now we're going to take 4 to the 7th power and then multiply that by 3. So we get a sub 8, or the 8th term, would be 49,152. Okay? All right, and the last one, 1, negative 4, 16, negative 64. So once again, we're alternating positive, negative, so our common ratio must be a negative number. So let's fill in a sub n equals, and we'll just go ahead and put 1 right here as our first term. And our common ratio now, we are multiplying by negative 4. Right? Okay, so now we put negative 4 in here, and we leave n minus 1. Okay, so now you can write it like that, or you can erase that 1 and just write it like this. Okay, so now we want to find the 8th term, so a sub 8 equals negative 4 to the 8 minus 1. So this is negative 4 to the 7th power. So when you type this into your calculator, make sure you put negative 4 in parentheses, and then raise it to the 7th power. So the 8th term in the sequence is going to be negative 16,384. Okay, and so I said put that in parentheses because if you don't, once you plug that in your calculator, here we get lucky because the exponent is an odd number. So it's going to be negative regardless, but we can also check to make sure in our sequence that the sign of the number is correct, right? This is the 2nd term, this is the 4th term. So it looks like our even terms are negative numbers. Our odd terms in the sequence are positive numbers. So the 8th term here would be an even term, and it's a negative number, so it checks out. Okay, so that is geometric sequences.